Hello everyone, welcome back to the DSC using C++ series. So I am Karan Punatkar, and in today's session we are going to learn about recursion. That is recursion, a powerful technique that helps in solving complex problem and elegant solutions. So here what we learning and covering in this lecture. So first one is that is what is recursion. Second one is the how recursion work with the stack mechanism. Then we are taking a example of factorial and Fibonacci sequence. Then we are taking a real world application of recursion. So without wasting our time, let's get started. So the first one is that is what is mean by recursion. So it's nothing but occurrence when a function call itself. In simple word, that is function call itself, okay, to solve a smaller part of the problem. It's like breaking a big problem into small sub problem solving each recursively. Okay, so the key point for of recursion is, I'm writing it here, that is every recursive function must have a base case, that is must have base case, okay, to stop the recursion. Then the second one is without a base case the function will result in an infinite loop. If base case is not there, result an infinite loop. Okay, so we are taking a small example of this. So like recursion function, so let's go to it. I'm writing the code, that is hash include clu include iostream. Then we are writing using namespace std, okay, and we are using void countdown, taking integer as integer n, and in this we are writing taking a condition, that is if n equals to 0 0, that is this is a base case. Okay, so in this we are writing like cout lift off, okay, and end. And after this we are writing it here, that is return 0. Okay, and then uh, just writing return, not return 0, because we have to call the function as well. So in this we write cout and taking a value of n and then applying just end. After this we have to start the countdown, that is countdown and integer n, and again it's not n, that is n countdown n minus 1. Okay, and take a semicolon again. This is the recursive call, recurs recursive call, and this is the base, that is I write it here, that is base case. Okay, and after this like this happened, then we write our main, that is integer main, and in this we write countdown equals to 5, and then we write the return 0. Okay, so let's run the code. I hope we did not get any type of error in this. So yeah, we get the output, that is 5 4 3 2 1 and lift off. Okay, that is the base case is if n equals to 0, which stop recursion. Okay, and for each call the function print n and call itself with n minus 1. Okay, so when n becomes 0, the recursion stop, that is we get the output, that is 5 4 3 2 1 and lift off. Okay, so this is a simple example of recursion. Let's now understand how recursion work internally using the stack mechanism. So let's go to our ppt. So yeah, every time a recursive function is called, okay, a new frame is pushed onto the call call stack, which keep track on the current state of the function. Once the base case is reached, the stack start unwinding. Okay, so we are going to check a visualization of the call stack for countdown 3. Okay, so we are here taking a countdown 3. So I'll just remove it out, and yeah, so like first it write countdown 3, then its call function calls countdown 2, then it's call countdown 1 countdown 1. Okay, and then last it's called countdown 0. Okay, and at countdown 0, like we are taking just a point, at countdown 0 it's print lift off, like countdown equals to 0, it's print lift off lift off. Okay, the stack unwind in reverse order, returning to countdown 1, then countdown 2, and then finally countdown 3. Understanding the call stack is key to debugging and optimizing recursive function. Okay, so we are taking an example of recursion, that is first one we are taking a factorial of number. then we are taking a Fibonacci series, and after that we are taking a real world application of recursion. That is, first one is backtracking, then tree traversing, and then divide and conquer algorithm. So first factorial of a number, that is, let's calculate the factorial of a number using recursion. The factorial of n, that is, we denote it as n factorial, is the product of all positive integer from 1 to n. Okay, so I will write the code here. So let's go to our editor. So just remove it out and start our code. That is, first we write integer factorial, and we take again integer n. Okay, and in this we are writing if again n equals to 0 and it's or, okay, or n equals to 1. Okay, and in this is a base case. I will write it here, that is base case. Okay, and then after this we write as simple like return 1, and that's it. Okay, and then after this we are again writing return. It's a formula of factorial, that is n into factorial factorial of n minus 1. Okay, this just a second, I will write it here, that is a recursive keys. Okay, and then after this we write our main function, that is integer main, and in this we are writing first integer number. Okay, number, we are taking number equals to 5 for factorial of 5. What we get? Okay, then we get 125. The factorial of number is this, and we print, and our last line, that is written 0. So I hope we did not get any type of error in this. So let's run the code, and yeah, the factorial of 5 is 120. If we take another number, that is, we are taking a 10. So let's run. So yeah, we get the factorial of 3628800, factorial of 10. So I hope you get like what I am saying, that is the base case, this one. Okay, the base case is n equals to 0 or n equals to 1, that is any one condition from this which return 1. Okay, and for other value the function call itself with n minus 1 and multiply n with the result. Okay, so I hope you get the answer, like output of this. So then next one, we are taking a example of Fibonacci series. So for that we are writing same, that is this one, integer n. Okay, just a second, yeah. And in this we are taking a right now, if n equals to 0. Okay, then we directly write it here, that is return 0. Okay, that is, this is a base case. Base, no, it's a base case. Okay, and again we have to write the another condition, if n equals to 0. We right now we are taking a 1. Okay, then we have to return 1, and this is also a base case for Fibonacci series, base case. Then after this we have to write, that is return that formula, return Fibonacci Fibona Fibonacci n minus 1 plus Fibonacci n minus 2. Okay, this is nothing but the recu, just a second, recursi, recursive case, or we can say call. Okay, it's basically, just a second, I have writing something mistake, Fibon, it's 1a not 2 here as well. Yeah, Fibonacci Fibona double c Fibonacci. Okay, so I hope we get, it's get error here. Okay, we write it here after that. Okay, that is written Fibonacci n minus 1 plus Fibonacci n minus 2. Just a second, yeah, it's a call. And after this we have to write the word, that is integer main, and in this we are writing our, that is integer term. We are taking terms equals to 6. Okay, and then we are again printing the Fibonacci series, that is printing, just comment Fibona Fibonacci series. Yeah, okay, and it's here, we apply, and after this we have to write like for integer I equals to 0. Okay, and I less than term, then we have to do that I plus plus, and after this we have to print the Fibonacci, and then we have to take the space, and everyone knows like the what our last word, that is written 0. We get the error in Fibonacci like name, but yeah, just a second, we run it out and we get what exactly the error is. That is line number 7, that is Fibonacci, and it's the take Fibonacci, that is we get using a Fibonacci. It's yeah, it's we did not, it's Fibonacci, not factorial. Fibonacci. I hope we did not get any type of error in this. So let's run the code, yeah, and we get the Fibonacci series of 6 terms, that is 0, 1, 1, 2, 3, and 5. Okay, that is the base case Rn equals to 0, that too we get a return 0, and n equals to 1, then we get a return 1. And for other value, the function recursively call Fibonacci n minus 1 plus Fibonacci n minus 2. That is, this is the formula for Fibonacci series. If you want to remember this, you can remember it out. It's very useful for you, like directly you can calculate the value and use in your function. So that is the next, that is a real world application for recursion. The first one is, that is backtracking. Okay, so it's nothing but using solving puzzle like Sudoku or the NQ problem. That is, I write here, that is Sudoku or n queen. It's not q, it's n queen problems. Okay, and then the tree traverser, that is recursive function are commonly used to traverse binary tree. Example, in order, pre-order, post order. That is in order, pre-order, and post order. Okay, and the last one, that is drive and conquer algorithm. Recursion is at the core of algorithm, like we exploring these as well, like merge sort, quick sort, okay, and binary sort. There are more than these as well, like search options or SEAR, search others. So we will explore this in the our next video. So today we will explore the basic of recursion and how it's work with the call stack. Then we are taking an example like factorial and Fibonacci series. Then we are moving to the real world application of recursion, and in the next lecture we will learn about binary search, that is this one. But before that, we will all check like what is meant by linear search and binary search, all that stuff. Okay, so thank you for joining today's session. So don't forget to like, share, and subscribe for more DSA tutorials. So see you in the next one. Bye bye.